Hi, I'd like to welcome everybody to this Confer Mentoring session just to introduce you to me and the AP Calculus workshop that we're going to be doing. So on this screen, you should be seeing just the Confer Mentoring logo and symbol. So I'm going to click. I'm showing a PowerPoint. And so this is a summary of what we're going to do in this session. We're going to do introduction. I'm going to talk about my AP experiences and some of my teaching experiences so that you can know a little bit about who I am. I'm also going to talk about the AP course itself and some things that you may or may not know, and to give you an idea of some things we're going to be doing. We're going to talk about the syllabus and list of topics. There should be a sample syllabi. They're on the AP Central website. But also, Confer is posting one, and it should be up. So you should be able to look at my syllabus. But remember, it's sort of specialized to the particular school that I was at. Also, I'm going to talk about a list of topics that are good to know to maybe get you started with so that you can start organizing maybe. Then we'll talk a little bit about materials that might be of interest to you. Resources that I find that are helpful. I don't recommend them unless I've actually used them. So, and I'll be giving you some of those as our time together comes along. And I really do hope that you'll sign up for the course so that we can meet once a month. And you can certainly feel free to call me more than once a month. I'll be trying to meet online once a month. And then also I'll be trying to talk to you individually once a month. And then I'm going to talk a little bit about some summer prep work that you might consider and talk about what I do the first few classes of AP Calculus. And then I'll give you some of my contact information so that you'll have that available. So anyway, let's continue. All right, I'm Dr. Deborah Britt. Debbie's fine. There's some pictures of me. We were having a little bit of trouble with the video, so we decided not to try that on this session. Anyway, there's some pictures of me I was an Einstein Fellow in Washington, D.C. for a good part of last year. And so these are some pictures on the left of me doing that job. And then on the right, you're going to see some pictures of me actually taking a course in guitar making and the final guitar that I made. So, and there was a lot of mathematics in that, interesting, and I learned a lot. My AP experience, I've been at lots of different schools. I've done rural schools, urban schools, what I would call suburban schools. My primary background is in starting AP programs, or I've been called in to improve an AP program. I've been in lots of different locales as far as schools are concerned. So I'm very familiar with different schools that you might be involved with. Every school has its own unique characteristics, so I think that we won't fit exactly what your school is, but I think we'll be able to find something close, and I'm sure I've had an experience similar. I've also been on lots of different schedules. I've been on block schedule where we did 4 courses fall, 4 spring. Been on block schedule where we alternated. I've been on blocks we split the period. We shared it with AP Calculus and AP Physics. And I've also been on 7-period days and 6-period days and 5-period days. And sometimes we, on 7-period, taught 6 classes and sometimes 5. And so I've had a variety of experience with schedules. And so what I'm here to tell you is that regardless of any of this situation that you have, you can make this work. It may not be ideal. I was at a school that had 27 snow days, and we were out almost all of February. So, and we made it work. So it can be done. I have experience mentoring. I mentor teachers, mentor student teachers. I work with teachers in school systems, mentor online. So lots of different mentoring, and I also mentor AP Calculus consultants and with College Board. So I was trained for that. I do consulting work for College Board. I do AP and pre-AP calculus mostly, although I've taught AP statistics. And I've been working at NSF last year with computer science, a new course called CS Principles that will have an exam coming up. So I'm familiar with the AP program, been involved since the 1980s, telling my age a little bit. I also have been involved for probably the past 10 years with the National Math Science Initiative in Kentucky, Maryland, North Carolina, and Virginia. And so I do a lot of prep work with students and work with teachers in the summer to prep them, a lot of new teachers that have never taught this before. So I think I'm really experienced. I don't think that's going to be a problem. And I do want to let you know that my very first year of teaching, I taught an AP course, and I never dreamed that I would be doing that. It was difficult, but I certainly had the background to be able to share my experience, strengths, and hope with you. Anyway, let's look at the AP Calculus course. As you probably already know, it's divided up into two parts: differential calculus, which is limits and continuity, derivatives, and then applications of the derivatives. And then the second part of it, which in some colleges and universities can be a second semester course, is integral calculus. Sometimes this is Calc 1, differential, and integral is Calc 2. We do integration, fundamental theorem of calculus, area volume, and then applications of the integral. So in the A course, the AB course, we cover usually more than what's in a one semester course in college. So we have to make sure we get everything covered. And I don't think I failed to mention that I've taught courses where we started in January and they took the exam in May. I've done that before. So it is possible to do that. But your students need to know that they're probably, when they go to college, going to have had everything in first semester calc, small part, and second semester calculus, depending on what university they go to. This is a list of topics that I would say maybe create folders for. These are probably the pretty typical topics that the free response questions on the AP exam come from. So you have two parts, multiple choice and essay, and there will certainly be multiple choice questions like these, but half of your test is multiple choice, half of it's free response, or what I usually say is essay. And so these topics are area volume, big theorems, change and accumulation, derivative computation, exam hints, interpreting graphs, justifications, what that means when you see that in one of the essays, limits, continuity, and definition of derivative. And these are not in any particular order as far as the course content is concerned. And sometimes there's overlap. Sometimes you're doing area volume early, and then you come back to area volume. It depends on how your textbook is set up or how you design the course. Particle motion, rates of change, related rates, Riemann sums and trapezoidal rule, flow field differential equations, table problems, and there's certainly not a lot of those in the textbooks. You have to hunt those. Techniques of integration and transcendental functions. And some textbooks, the high school textbooks typically have transcendental functions separately later in the course. The college textbooks put this right up front and use these all year long. And there's advantages to both, and we can talk about that in our session. The materials you'll need. You are going to be given a textbook probably that your school, somebody else maybe even has chosen. So you can, whatever you're dealt, you can work with it. Preferably your textbook will have some AP problems included in it, but it may be the newer edition. That may not be possible, but what I would strongly suggest is that you get 5 or 6 textbooks for you to have on your desk so that you can refer to something. If you're looking for one that has good AP problems included, the second edition of the Rogowski book has lots of AP problems at the end of each chapter, except for I think the first chapter, which they sort of consider a pre-calculus chapter. You're going to need a graphing calculator. It's required on the exam. I've dealt with TI-84s and Inspires primarily. but I've also worked with Casio. Haven't done with Sharp in a long time, but whatever calculator you have, we can work that out. We may have to do that sort of individually. And if I don't know the answer, I know people that do consulting works for all three of these companies, Texas Instrument, Casio, and Sharp, that can answer our questions if we have trouble with that. So I typically use a TI-84, and unless there's, you know, a large group of people in our session that use the Inspire or something else, I'm probably going to stick with the TI-84, and I also have the emulator for my computer that I'll be using from time to time. Extras that you might try to be accumulating are Calculus in Motion. It's a software program that you can purchase from Audrey Weeks. You do have to have Geometry Sketchpad on your computer for it to move, but she has done an incredible job of taking all the AP questions and making them dynamic, and a lot of visualization, a lot of motion that students, I think, get a deeper understanding from. Also, if you have smart boards, there's some cool things that you can do that I think help the students see things better. If you have a smart board, fine. If you don't have one, fine. But I think interactive technology is something that that I think students are sort of geared to, and so they appreciate the attempts to use it. And a lot of stuff has recently come out that you can use, and you can certainly use iPads and apps and things like that. Not that I think any of this is necessarily going to make that much difference in how your kids do on the test. I think that's all about content and understanding. And then any materials that you find on AP Central, they have tons and tons of old tests. They have tons and tons of sample curriculum, sample syllabi, and so please get familiar with that site. Just Google AP Central and you'll find it, but there's tons of stuff in that. Look under examinations for the particular test questions. And one of the things that you could be doing is going ahead and getting questions. You may not be able to sort them because some of them cover multiple topics and put them in your folders for your topic, but you could go ahead and be accumulating the questions so that you'll just have them easily at your disposal. And these are resources, old AP test questions, any of them that you can get from any location, especially if it's been on a test. There are Form B questions, which were given to students on another exam other than the one that most of the students took. There are all kinds of questions that you can get. Just make sure they really were on an AP test question. There's lots of books that you can buy that say they're AP questions, and a lot of times the writers were people that have helped write AP test questions before. I've helped write test questions. I've also scored the AP exam for a long time, and so there are some really good quality test questions that aren't necessarily in your textbook. Accumulate a variety of calculus textbooks. I would go on the AP Central website and look for the typical ones that we see. So Rogalski is one. It's not one I've ever taught out of. Anton is another one. I think Steve Davis has now edited that. Dan Kennedy has taken over and done some work adding in some technology for what used to be the Demand Awaits book. Paul Forrester has a great book. Osterby Zorn have some great books. So there's plenty of good stuff out there. And I would accumulate as many as you can so that you can look stuff up and say, well, my book isn't doing a very good job, so I need another book. Games and activities that you might do. A lot of my high school kids tell me the teachers don't do that much with them anymore, and I think they appreciate the effort that you make in trying to make things interesting. The North Carolina Association of Advanced Placement Math Teachers has newsletters, and those are online. They have a website. They come out twice a year, once usually in the spring, about March, right near the AP exam, and then again close to the 1st of August, right before school starts. And that August issue will always involve the most recent test and a discussion of how it was graded and what kind of points were taken off for and what kind of points were given credit for. Also, resources that help you with verbal numerical, analytical, and geometrical approaches to teaching, because the students are going to need to see a lot of that. In other words, we try to take one problem and look at it in all of those different approaches, and especially the verbal, being able to communicate well what the student knows, and so that's a critical component. But the numerical I would think of as more the tabled approach. Geometrical would be some of Audrey Weeks' stuff, and graphical, where you draw a picture, interpreting that picture, interpreting graphs. That might be another whole folder that you could create. And then the analytical is what I call sort of the typical old way of doing it, that most of, well, I won't say that, but a lot of the people that are my age, that was all we ever saw, was the analytical version. But anyway, we're trying to look for, you know, how do I approach problems in all four of those different ways. What you can do to help you get ready for next year, if at all possible for your summer preparation, if you can take a week-long or a 4-day, 3-day, whatever you can get hold of, Summer Institute, sponsored by some of the colleges and universities. They usually, if it's called an AP Summer Institute, then that means they're using certified AP consultants. I'm doing one in August, one of the first weeks in August at William and Mary. They're all over the state of Texas. Texas has an outstanding group of people that do workshops, and so Ray Cannon is one of those. And so you can look online and go and find one near you and see if you can go to one, because that is really helpful. It's a lot of content, and I find that's what most people need. And then if are you ready for calculus is a PDF that is also posted on the Confer website. I gave it to them to post, and so I'm assuming it's there. It's just basically a test for students to sort of look at and refresh themselves on the pre-calculus concepts, and some questions are in a little bit different way as to which students can actually think rather than just memorize. Also, I compose a parent letter. I usually send these home in February or March whenever the school is doing registration for the next year. But in some schools, when I've shown up new the first day of school, I give out the letter at that time. I usually have the student and the parent sign these, saying that they're aware this is a college course, that they're aware there's going to be substantial homework. I try to, have 1 or 2 hours a night, and not as much on the weekend. But I let the parents know that this is a college course, and that both the students and the parents are willing to support whatever it takes to get that work done, and try not to overcommit themselves to, too more than they can handle, too many AP classes at one time. So, and then I start out the beginning of the year with a functional approach. Some students have never seen this before. If they've had me, they have, but this is one thing that you might can sort of do. I would strongly recommend that you not spend the first few weeks of school doing pre-calculus review. I think it helps to set the tone that this is a calculus course, and that you immediately start doing things in pre-calculus, but from different perspectives. So if the students have had a lot of what I'm going to talk about in a minute, which is this stuff down here at the bottom, then look at it from a different approach. So what I want to do now is sort of just look at a problem that sort of involves what I'm talking about here. And we'll be doing some of this in our first class. I'll be, sending out assignments from time to time and having you work problems, and then we'll have sessions where we can discuss those. But we'll probably be taking a couple of topics each of the monthly sessions that we have. So I'm going to close this out for just a minute, and we'll come back to that. And then I'm going to, okay, hope you can see that. Let me enlarge it for you. Okay, this is a problem that is what I'm talking about, where I just draw a graph. Notice on this particular function, I did not give the equation for it. And as a matter of fact, when I do this a lot of times, I don't even put coordinates on there. I want them to have the idea of how things change and how they move. I don't want them to be calculating things. I think to start with, putting the numbers on here from -2 over to 3, and then each one of these I'm letting be a 1. So that they can, some students, it will take them a while to get the hang of it, or they'll need to convince themselves as to what's happening. And so it would be good to label some of the intercepts, the x-intercepts, and also the maximum minimum points that you might have. The students will be able to, if they can take a number and say, okay, well, where did this point move? It was when x was 1, I was at 0, but now I'm 1 somewhere else. And so convincing themselves as to what happens. So what I do is I provide them a sketch of some sort, and I just try to make them more complicated as time goes on, but this would be a basic simple one. I want them to be able to tell me the domain and the range and write those, in nice mathematical, notation. And then I want them to be able to give me the domain and range of these changes as well. So when it moves left or right or up or down or whatever, then how does that affect the domain? How does that affect the range? So I would have them do each of these, take the initial graph, and then I want them to find that same function evaluating x plus 2. Now, another thing you might consider is if you plug a function, where you do have an equation into y1 on the graphing calculator, then in y2 you can go y1 of x plus 2 and actually see it. So you could start with a simple cubic function or a parabola or something and have them do some of that and say what happens, when I do that. But I need students to know the difference between f of x plus 2 and f of x plus 2. So I need them to know that this moves left, not right. They'll think it moves right. And then how many places right? It's going to go, left. It's going to go 2 to the left. Then I need them to know that this goes up and down. This affects function value, so that affects your range. This affects the x value. That's going to affect your domain. And so I need them to very quickly be able to do that kind of thing. It's not calculus, but it's maybe a function approach that they haven't seen a lot of, and they need to be able to do quickly. And so I need them to be able to take all of these and the absolute value. What does that do to the graph? One good way of doing that, and this, when I put this down, it may be a bit of a glare because I'm using a transparency, but one good way of doing that is just take, and then if you will just copy that function, and then you can very quickly go through and say, okay, if I'm doing number 1, okay, and you might do a graph where it's a little more, but I need to move 2 to my left, so there's 1, 2. And now I can look at the blue graph and see what my new graph looks like. If I need to start here and go up 2, I can go 1, 2, and I can see what my new graph looks like. So some of the course is going to be not only working problems, but talking about maybe different ways that you can do that. So I think transparencies, even though we don't use them as much anymore, they're a little old-fashioned. We can move things around, and you can do that on a smart board as well, a little bit different way. So let's get out of that. Okay. We'll X out of that and go back to our PowerPoint. So give me just a second. And during the class, you'll be able to hear me. I'll be able to hear you. We'll try some showing a video, but sometimes it slows the computer down, especially if you've got more people online. So, but if I'm one-on-one with you, we certainly can do that a little bit more. All right, this is my contact information. You have my mailing address in case you need to mail me something. I live in Mars Hill, North Carolina, which is in the mountains, not far from Asheville. This is my home telephone number, 828. And that should be 689. That's an error on the slide. So 689-5863. That's my home phone number. And then my cell number is 828-691-1028. And then my email address. So you feel free to contact me anytime. You don't have to wait till the course starts. If you've got any questions about, how things are going to work, feel free to call me. If you have any questions over the summer about content, I'll be glad to answer them. And I really, really appreciate your taking the time to look at it and consider the course. and be thinking about this. I think it's a great opportunity for you, in Texas especially, where they're helping to contribute. So thanks, and I hope you all have a great rest of the summer, and I look forward to meeting you all in September. Bye.